Welcome to this explainer. Today, we're diving into a massive, frankly, a real game-changing shift happening in modern commercial farming right now. We are talking about the transition away from those traditional inorganic fertilizers over to highly efficient chelated microelements. If you're involved in agriculture, you already know that the choice between a basic inorganic salt, like zinc sulfate, and a chelated form, like EDTA, can quite literally determine the success or failure of your entire crop. It's that big of a deal. So let's unpack the hard science behind why this shift is absolutely crucial. For decades, traditional agriculture has leaned heavily on cheap, simple, inorganic sulfates. I mean, they were just the standard, right? But according to a really eye-opening 2019 study in the Chinese Agricultural Science Bulletin, this heavy reliance comes with a massive long-term environmental cost. The problem we're facing isn't just about what we're putting into the ground. It's the stark, frankly alarming difference between what the plants can actually absorb versus what just gets left behind in the soil profile as toxic waste. So while those traditional inorganic options cause serious environmental strain, chelated fertilizers use this incredible structural specificity to safely deliver nutrients. Here's the technical breakdown of what's actually happening. Inorganic sulfates are just simple ionic compounds. When you apply them to alkaline or calcareous soils, the metallic ions, like your zinc, iron, or manganese, they immediately react with hydroxide or phosphate ions in the soil. This creates what's called the lockout phenomenon. Basically, it turns into this insoluble sludge that plants absolutely cannot absorb. It just stuck there. But chelated microelements, they have this molecular shield. They literally cage the metallic ion, keeping the nutrients 100% available and incredibly stable across a huge pH range. Now, because these shielded nutrients aren't getting locked out in the soil as sludge, the plant can direct all of that raw material straight into its metabolic centers. And the results are wild. That same Chinese Agricultural Science Bulletin confirmed that this highly efficient delivery visibly improves the plant's appearance and dramatically increases chlorophyll production. But it doesn't stop there. It actually changes the internal structural quality of the harvest itself. We're talking boosted vitamin C, higher carbohydrates, better proteins, and even extending the storage life of the produce. It's upgrading the crop from the inside out. What's fascinating is how this science manifests physically, like with the EDTA mix, which comes as a pure green powder or as easily applied granules. These forms are an absolute powerhouse for foliar absorption. Think about it. A plant's leaf cuticle is naturally negatively charged, so when you spray inorganic salts, they're often just repelled, or they just sit there on the surface and cause nasty leaf burn. But chelated micronutrients are electrically neutral, or they carry a very specific optimized charge. This means they slip right through that leaf wax and the stoma so much faster, delivering nutrients straight to the plant within mere hours. Plus, they're 100% water-soluble, meaning they are totally safe for your drip irrigation systems. No more clogged lines. All right, for the commercial buyers out there, I know hard data is everything. Let's look at the specs for a fresh 5,000 kilogram batch with a solid 2-year shelf life. The certificate of analysis highlights a 1% solution pH of 7.7. And this specific pH detail, it is highly, highly relevant. When you are dealing with alkaline or neutral soils, so anything with a pH greater than 6.5, chelated fertilizers aren't just a nice-to-have option, they are mandatory. If you try using traditional sulfates in a 7.7 pH environment, it is a complete waste of resources because those nutrients lock up and turn to sludge almost immediately. Because these batches conform so perfectly to strict in-house specifications, we really have to talk about the economic return on investment, the B2B math. Look, inorganic sulfates might look like a bargain up front, but their nutrient use efficiency is often sitting way below 20%. That means you are quite literally throwing away over 80% of what you apply. On the flip side, chelated fertilizers boast a massive efficiency rate of 80 to 90%. So the math is undeniable. You might actually need to buy and apply 5 kilograms of zinc sulfate just to get the same nutritional uptake as 1 single kilogram of EDTA zinc. When you factor in the extra labor, the shipping, and the potential yield loss, chelation is just vastly more cost-effective. Within this specific mix, you're getting a highly precise, fully shielded primary nutrient load. We've got zinc EDTA leading at 5.1%, followed closely by iron EDTA at 4.2%. Then you have manganese and boron both sitting at 2.1%, with copper EDTA rounding it out at 0.5%. And remember, every single one of these metallic ions is safely locked inside that EDTA molecular shield. It's a perfectly balanced cocktail, ensuring the plant gets exactly what it needs, exactly when it needs it, without having to fight against the soil's chemistry. Now, to maintain absolute transparency here, we do need to address a very common question regarding real-world application. While the science of chelation and this rigorous quality analysis are totally undeniable, currently we don't have specific field data for this exact EDTA mix batch used in Southeast Asian agricultural crops. We know for a fact that chelated fertilizers broadly elevate crop yields on a universal scale, but those highly regional case studies for this exact formulation in those specific climates, well, they're still pending. Our goal is always to give you the exact facts as they stand right now, empowering you to make the best local decisions for your own operations. So, given the undeniable environmental and quality benefits we've covered today, how will upgrading to chelated fertilizers transform your own agricultural success? Let's recap. If you're working with acidic soils, a pH under 5.5, traditional sulfites can technically work, sure, but chelated forms are still the preferred choice for a much faster correction of deficiencies. But in neutral to alkaline soils, they are an absolute necessity. By entirely bypassing that lockout phenomenon, boosting your foliar absorption efficiency, and delivering a massive return on investment, EDTA products truly represent the cutting edge of crop nutrition. So, looking at your own production goals, isn't it time to finally leave the inorganic waste behind?